So we have the function g of t equals 1 divided by the quantity t plus 2, and then subtract 1 afterwards. So g of 0 means, right, that 0 is the input. So that's going to take the place of t everywhere we look in the function. So it'll look like this. 1 over 0 plus 2 minus 1, or a half minus 1, which is negative a half. Okay? That's that one. What's different in the second example, in this one here? Right? Is the input still 0? Raise your hand if you think the input's still 0. Raise your hand if you think it's not 0. Oh, good. Lots of hands. That's right. Now what I'm saying is, like I said earlier in the previous example, that the output is 0, and we're saying what input yields an output of 0. Okay? So all we're going to do is just take that function up there and set it equal to 0. So we get 0 equals 1 over the quantity t plus 2 minus 1. And we have to try and solve this. I'm curious, did anyone just look at it and know what the answer was? Here's sort of, I'm going to do this problem 2 ways. I'm going to show you how to do it algebraically, and then I'm going to discuss with you how you can look at the problem and sort of see the answer without doing much work at all. Okay? So here's the algebraic way. We could start by adding 1 to both sides. So we'd have 1 equals 1 over t plus 2. And then lots of times we'd like it to look like there are 2 fractions equaling each other so we can cross multiply. So I'll put this 1 over 1, and we'll cross multiply. And we get t plus 2 equals 1. We'll subtract 2, and we'll get t equal to negative 1. Raise your hand if you agree with that answer. Okay, good. This obviously wasn't a problem. What I'm curious about is if any of you thought of it this way. What we know is if we look at just this expression here, we actually know what that expression by itself has to equal. Without even doing any algebra or anything like that, we know that this thing in blue, that's circled in blue, minus 1 has to be 0, right? So what do we know about this fraction circled in blue? Has to equal 1. If you didn't see it that way, you just did the algebra, and you ended up with the same step. Like over here, you saw that it was equal to 1. So you want this to be equal to 1, and now we just need to think of the following idea. Here's this fraction again. I want a fraction that has 1 as a numerator and something as a denominator to be 1. What can we promise us? What do we know about this denominator then? What does this denominator have to equal? This denominator would have to be equal to 1, because 1 divided by 1 would give me 1. So now I'm just saying, hey, well, t plus 2 has to be 1. Okay, well, something plus 2 equals 1. That something must have been negative 1. It's just a comment. I think sometimes we get wrapped up in the algebraic processes so much that we forget that we can just reason out a lot of these things. Okay, let's go to the next problem. We have a function up here, g of x, that tells us to do something to a number. What does it tell us to do to a number that we give it? Right. So this function says, take the number you use as an input, square it right here, and then add it to itself. Add it to the number that you squared. Okay. So what I'm doing in this problem, though, is I'm not giving it just numbers. If you notice, we're plugging in another expression for x. Okay? So sometimes this makes people a little bit confused, but what you should realize is now this whole thing is the input. The input is negative 3x. So what does g of x do? Whatever input you give it, it squares it, and then adds it to itself. Okay? Here's a good example. Suppose I had said, hey, find g of d. I don't know why I used d-e-e. Okay? Although I see a few chuckles out there. Well, d is the input. What do we do to d? We square them. We square d, and we add another d. And then you have a family. Okay. You guys can think about that. It's a bad joke. Okay. So now the rest of these are kind of the same thing. Some of them are a little bit more fun in terms of the algebra you might end up with. Back to this first one here. When you square negative 3x, it means negative 3x times negative 3x, you get 9x squared minus 3x. And I guess this is okay to leave it. If you want to, you can take out a common factor, but I don't know that really gets you that far. Okay? You need some scary looking ones. Let's look at part C for a minute. So now this whole thing is the input. So remember, g of x takes an input, it squares it, and adds it to itself. So it's going to be x plus pi squared plus x plus pi. That's it. Now this I would make some attempt to simplify and collect like terms. We know to square something means to multiply it by itself. So you get this plus x plus pi. And this is basically algebra from, this could be back in 9th grade for some of you, right? Algebra 1, some of you are in 9th grade, so it's back in like 7th grade. Okay, so if we start to square this, we just multiply all the terms that, like this. Some of you use the word FOIL. Not crazy about that. It's really distributive property twice. X times x is x squared. X times pi is plus pi x. You have plus another pi x and plus pi squared plus x plus pi. Okay. So there's sort of one little fun thing here. We're going to look for like terms to add together. X squared, there are no other x squared terms, so that'll be sort of by itself. This is really an x term. It's pi times x. Here's another one. That's an x term. And here's another x term. Doesn't have a pi in front of it. Its coefficient is 1. So here, this will be kind of fun for you. Ready? Pi plus 1 is 2 pi plus 1 times x. So I've combined 3 like terms together to get that. And then lastly, pi squared plus pi. Okay? That's one way to write it. I guess we could do a couple other things. Alrighty. I guess I'll focus on this part E. This is some tricky algebra, and we'll see what happens. Okay? Again, this whole thing is your input. What does g do to a function? It squares its input and adds it to itself. So you get 1 over x plus 1 quantity squared plus 1 over x plus 1. Okay. So we have some options in terms of how we proceed here. I'm going to think of it this way. I'm going to think of this as just 1 over, because 1 squared is 1, and then on the bottom I'm going to write x plus 1 squared, and I'm not going to bother to multiply that out. And to that I have to add this fraction. Okay? But before we can add fractions, we have to have a common denominator. And my claim is, because I've left this first fraction looking the way it is, it's sort of easy to see what the common denominator is, right? This denominator here, over on the right here, needs another x plus 1. So we multiply by x plus 1 on top and bottom. Okay? Alrighty. So now we're ready. So you get 1 over x plus 1 quantity squared plus 1 times x and 1 times 1, just give you x plus 1 over x plus 1 quantity squared. So we get x plus 2 over x plus 1 quantity squared. Okay? Not so bad.